Howdy folks, and welcome to the channel. In this episode, I'll be teaching you guys how to load seismic and well data into Petrel, as well as how to position your well logs inside your seismic surveys. So as you guys can see, I've already opened Petrel and everything is ready to go. The very first thing we do when we're working with Petrel is to load data, right? The easiest way of doing it is to use the input sidebar that we have here. So just right click on it. We click on the import file, then we get this dialog, the import file dialog. Okay, this is actually a very important dialog for loading pretty much anything you want, right? But it gets a little tricky, so you guys have to be very careful when you're working with this. The problem comes from having to specify the type of data you're trying to load. Whatever data you're trying to load, you have to specify its type. And if you don't, or if you just forget to specify the type of data you're loading each time you're loading a data, the application would definitely crash. Specifically when you are trying to load seismic data, okay? So you have to be very careful about this. When it comes to programming, guys, we have best practices. One of these best practices is called exception handling. The fact that there is a possibility for your application to crash is on and off itself extremely embarrassing. So when you're loading seismic data, you've got a couple of options, but the most straightforward way of loading seismic data into Petrel is to choose SEGY seismic data. ZGY is kind of, I think, the Petrel's proprietary format. Also, you can load ZGY files. We also have this option, SegY seismic data with preset parameters. This is for when Petrel can't load your data and you have to specify like the byte positions for where the information actually is. It's like your data isn't standard enough for Petrel to be able to load it. So what we usually do for standard data sets is SEGY, SegY data. This is what we're gonna go with, okay? Then you choose your seismic data. I'm gonna go with the example I've prepared for you guys for this tutorial. So everything is set up here, guys. We can see the name, the type of data, the template, the domain. Guys, by the way, this is a confirmation dialog, okay? You just confirm that the Petrel understands your data in the correct way, right? By the way, here you have two options for elevation time domain or elevation depth domain. Make sure you're specifying the right type of domain for your data. Changing this would not change the nature of your data. Seismic data is inherently in the time domain. You can convert it to the depth domain using different conversion methods. The data set that I have right now is in the time domain, so we're gonna go with that. And I'm just gonna click OK for all. All right, now that we got loading seismic data out of the way, you might wanna take a quick look at your data. So you can simply open up a 3D window, toggle on your inlines and cross lines, and the very first thing that you see is a view from the top. And if you rotate your data, you can see the data quite easily. So the very first thing I do is that I turn on the anti-roll, because you really don't want to look at your data like this. You want it to be like this. Now that we've loaded seismic data, we're gonna go ahead and try to load well data. So well logging data comes in different formats. There's a recommended order for loading well related data. The very first thing you guys have to do is to load well heads. I already have the well head and well head here. Then we open, OK for all, and OK for all. Now we got our well heads. Well heads kind of show the position of wells. The second thing we do is to load the well log itself. I'm gonna go with well log's ASCII, okay? I'm gonna start with the first well log. As you guys can see, because we've already loaded the well heads, it can easily find out which well log we're loading and which wellhead it belongs to, right? It's going to auto-detect logs. If you want, you can specify which wells you want, but for now, we're just gonna auto-detect the logs and we're just going to accept. The second thing we would do is to load the deviation file for the first well. So deviations are per well. For each well, you get a separate file, but wellhead is one file for all the wells you have. I'm gonna go this time with deviation or well path. This will let Petrel know about the deviation or the path of the well you have, and how the coordinates of each point vary across the path of the well. Either way, you have to load well path, whether your well is deviated or not. Deviation file for the first well, okay, no problem, okay. Now we can see where the first well log is. You might think that, all right, our work is done here, but that's not the case. As you guys can see, right now we're in any domain. Any domain is not a real domain. Thing is, well logging data is in the depth domain. Seismic data, however, is inherently and often in time domain. Now what we need to do usually is to convert one data from one of these domains to the other, so both data sets are in the same domain. For converting seismic data into depth domain, we would need the velocities that come from processing seismic data to convert the seismic data to depth domain, okay, using the DIX conversion. But right now we're going to try and convert well logs from the depth domain to time domain. Let's see how that works. If we actually go to this is the depth domain, this is time domain, and any domain. If you go to time domain, you would see that all the wells disappear, right? The wells are not here because they are in the depth domain, right? And the seismic data is in the time domain. So what do? There are different ways of doing this depending on what kind of data you have available. One of the ways you can do this is through using the slowness well log data. If your well logging data comes with slowness, you can use this to convert your well data into the time domain. And now for the 3 wells that we loaded, we can see the length of the wells greatly differ from the lengths we saw in the any domain. In the any domain, they look much longer than they appear in the time domain. Always look at your data in one of these domains. Then you can actually do your interpretation, all right? But what if you have more information? When it comes to well logging data, sometimes we have more information. By more information, I mean check shot data. This could actually help you tie your wells better to your seismic data sets. All right, now let's load the check shot data with check shot format. Okay for all, and we are done. Now, what you guys have to do if you want to have like a better seismic to well tie, you go in the seismic well calibration module of Petrel, seismic well tie. All right, I activated the time depth relationship based on the DT or based on the slowness well log information. But this time we also have the check shot. Okay, let's see how we can use both. We could use either of them, but most importantly, we could use both of them to create a seismic to well tie that is kind of more accurate. So let's see how we could do it. We have the DT, we have the check shot data. Okay, we just go ahead and click OK. Let's see what happens. Okay, so the most important thing you need to do, you have to go here, well tie editing, and you have to click on knees at check shot, create knee points at check shot samples. This will calibrate slowness information using check shot information and make everything more accurate. So after doing that, we're all set. We just need to go here, and this time we're going to choose the seismic well tie sonic calibration. As you can see right here, we're going to choose this one now. Okay, and we're going to tap on run. Shouldn't take too long, but we only did it for the HD1 for the first well log that we had. That's why all the other ones are gone. You have to do it for all the well logs you have, right? So okay, and now we can see that this is the actual two-way time length of the first well log. This is much more accurate. Okay, now what we're gonna do is to Now that we have correctly positioned our well log inside the area of the seismic survey, now we can actually open a interpretation window, right? And then we can, so before we go here, we have to do something very important. What we need to do is to position both inline and crossline sections on the well log. It's going to be pretty straightforward. You just have to go in the intersection tools, intersection player, and then choose like the step. I think increment 1 would be accurate enough for what we're going to do here. All good. So now when you do this, automatically on the interpretation window, everything is in the right place. Now, all we need to do is to turn on the inline slice, for example, and turn on our first well log. You can perfectly see the position of your well log on top of the seismic data. So both of the data sets are in the same domain, and now you're allowed to start your interpretation task. I'm also going to show you the crossline as well. There we go. By the way, I really want to show you guys the problem Petrel has with exception handling when it comes to loading data. So when we open the import file dialog and when we want to load whatever data we want, if you forget to correctly specify the type of data you're trying to load, the application will crash. And this is a horrible thing. Keep in mind, this is not acceptable. Just because it was our fault, it doesn't mean the application is allowed to crash. In programming, when you're creating applications, you have to adhere to best practices. And clearly, Petrel does not care about that. Exception handling is very important. Here we go. As you guys can see, it's having a hard time to load the data. What should have happened is that we should have gotten some kind of a message box. But what happened right now is that the application completely crashed. All right, let's see how we could do the exact same thing using SeismicFlow. So I've already opened the application, it's ready to go. All we need to do is to go to the Files tab, and here we have two options, right? So you could either use the recent files that in previous sessions you worked with, so we can simply use these, or you could just choose what type of data you're trying to load, and then it opens up a input dialog window, so you could just choose whatever data you want. So I'm just gonna load the wellhead data, then I'm gonna load the first well that we had, then I'm gonna load the seismic image. Simple as that. Now all we need to do for positioning the well logging data inside the seismic survey is we have to go here in the context menu. We have to choose upscale well logs. Then you have to choose what well and what well log you want. So I'm just gonna choose the depth. All right, now that it's ready, let's go ahead and take a good look. All right, as you can see guys, we have the full length of the well. We can perfectly see it, right? Let's take a good look in two-dimensional view. So I'm just gonna first show you the inline and then the cross line. There you go. As you guys can see, here we have our well, which is perfectly tied to the seismic data. And also let's take a good look at the cross line section. And there you have it guys. As you can see, it's right here and is perfectly aligned with TWT, two-way time, and it shows that it's correctly tied to the seismic data. Now, what I'm going to do for you is to show you how we can do this for the rest of the wells. These are all the wells that we have for this area. And let's see how this would work. It's going to be very easy. We do the exact same thing. We're going to select all the wells. Then this time, for example, we could select P-wave velocity. All right, so let's take a good look. And there we have it, guys. This is how P-wave velocity changes across the survey area, as you guys can see. Then we could also show a couple of slices. Let me show you these slices. Couple of inlines and cross lines. As you guys can see, we can perfectly see the wells where they are, and we could see the seismic image as well. And I'm just going to zoom so you could see everything better. Then we could also, move the slices around. As you can see, just like Petrel, we could move the slices around so you could see where the seismic data actually cuts through these wells. See? So these are where we have the wells. It's perfectly positioned. Both of them are in time domain, so it's perfectly reliable, as you can see. And everything really happens automatically. The application automatically creates the time depth relationship, and it is just as accurate as Petrel. By the way, I wanted to show you guys what happens when you try to load seismic data as deviation file path into SeismicFlow, because if you guys recall, we did the same thing in Petrel and Petrel crashed. So I'm going to load a deviation file into SeismicFlow for well number 4, set deviation file, and we have a seismic image here. As you guys see, nothing happens. Let's try to do it with another type of data, for example, well logs. Let's try to load a seismic data instead of a well log. Let's see what happens. You see, it gives us an error. Instead of the whole application crashing, it just tells us that the application ran into an error because there was a problem with reading a specific byte of the data, right? So we need to be very careful about exception handling when we're writing applications. That's about it, guys. Thanks for watching. If you liked the video, make sure to like, comment, and subscribe. Let me know your thoughts down below, and I'll catch you in the next one.